think of numbers as the building blocks of mathematics, really algebraic expressions are the concrete that holds it all together. These are the most important things in mathematics, and it's so valuable to really, at the very beginning, understand what these things are and how they're used. So I want us to take a look at some algebraic expressions and see what it means to evaluate an algebraic expression. I want to start off by looking at a little table here. So here's a little table where I see various different values for x, and then I have this simple algebraic expression, which is just x divided by 5. And all I want us to do is to figure out the values for this algebraic expression as the values of x change. Now this is so valuable. You see, x here is some variable. That means that it's changing. It's some number, but we don't know what the number is, and the number might be changing as we go through a particular question or look at some instance or circumstance. So now the question is, when we change the unknown x, how does that affect this expression? Well, let's take a look and see. So for example, when I let x equal 20, then I'd put a 20 in for x, and so I'd see 20 divided by 5, which you notice is indeed 4. So we're off to a good start. Someone already started to fill this in. Now our job is to see if we can fill the rest of it in. If I now change x to be 50, then this expression is going to be 50 divided by 5. I can evaluate it by just computing what is 50 divided by 5. Well, 50 divided by 5 is 10. So the answer here, this expression, would be 10 when x equals 50. What about if I upped x to equal 60? Well, then I have 60 divided by 5. And what would that be? Well, if you take 60 and divide it by 5 and perform that division, we'd see 12. So here you can see differing values of x yield differing values for this particular expression. This is the key thing. We're going to be changing one variable, and we're going to see how it impacts an expression. Let's try another example together. This example looks a little bit more complicated. Let's just take a look at the expression first. I take 3 plus 5m, and then I square the whole thing. These parentheses tell me that I'm taking the quantity and squaring it. And by the way, this m here, with the 5 next to it, since there's no symbol written in between, we understand that's actually invisible multiplication. So this is actually 3 plus 5 times m, quantity squared. Okay, now let's change the m and see what happens to the expression. If I let m equal 0, then I put a 0 in here. 5 times 0 is 0. I see 3 squared, which is 9. So the person who put this in did it correctly. What about when I let m take on the value 1? Well, we return to the algebraic expression, but wherever we see an m, we're going to insert a 1. So I see 5 times 1, that's 5, plus 3, that's 8, and now I square the whole thing, and so I see 8 squared, which is 64. You see how this works? Let's try another one. Let's let m equal 2. If I let m equal 2, then if I plug that in, I see 5 times 2. Well, that's 10, and I see 10 plus 3, that's 13. So now I have to square 13. But I happen to know, that's one of the ones I actually know, if you square 13, you get 169. I know that because I've been teaching math for 1,000,000 years. So 169 is the answer, and you can see that I can evaluate this algebraic expression by just inserting this particular value, whatever value I pick, for the m, for the unknown, for the variable. That's all there is to it. Seems kind of simple, but this is going to be really the foundation for everything we're going to think about together, and even beyond. Cool.